Hello everyone, welcome to today's tutorial. I'm going to be looking at Python's square root function. First, we'll take a look at what is a square root. Then we'll take a look at the square root function in Python. And finally, how we can use the square root function in a real-world example. To begin, let's take a look at actually what a square root is. Square in mathematics. So here's the technical definition. In algebra, a square, here represented by x, is the result of a number n multiplied by itself. So basically, we have n with a special number 2 above it, meaning squared, and that results in the square x. The 2 basically means two n's multiplied by each other, giving us x. So as an example, we can look at 5 squared, which is 5 times 5, gives us 25. You can see in both these examples we're going from the root, n or 5, to the square. But what if we wanted to go the other way? What if we have 25 and we want to find the root of that square? That's where the square root comes in. This is a special syntax in mathematics that shows the square root of 25. Now let's take a look at the square root function in Python. The square root function in Python is part of the math module. We'll take a look at that in a second in using the square root function. Then we'll take a look at square rooting positive numbers, 0, and negative numbers. So for the square root function, the input is one parameter, a number. And the output is that it returns the square root of the input as a floating point number. Square root is a part of Python's math module in the standard library. So to use it, first, we're going to go into our Python interpreter. Now once here, we'll just import math. Now it's available for use. So to begin, we'll take a look at the square root of a positive number. We can do this with both integers and floating point types. So for integer, we want the square root of 25. That gives us 5. We can double check that by multiplying 5 times 5. Obviously this is a pretty basic example, but I want to show you another syntax we can use. Within Python, you can do squares by doing a double multiplication sign and then a 2. This basically means 5 squared. And we get the same answer. This will be useful later when we have more complicated numbers that we want to check. So for example, when we try a float, let's take the square root of 70.5. Here we can see it's a pretty long number. We wouldn't want to type all that in, so instead, let's assign it to a variable. And now, rather than typing all that in twice, we can use our newly discovered syntax and do x squared. Gives us 70.5, and that checks out. Let's take a look at taking the square root of 0. May not seem like you do this a whole lot, but this can be useful. As we just saw, sometimes you pass a variable into the square root function, or you're squaring a variable. It'd be useful to know if that's going to break if we pass in a variable that contains 0. So here, let's double check this. Oops, forgot our math. There we see it's 0.0. Yep, same result. Let's take a look at using square root of negative numbers. So negative numbers are not valid numbers to pass the square root, and this is because you cannot multiply two different numbers to get a square, and essentially a negative and a positive are different numbers. If we have a positive 5 times a positive 5, we'll get a positive. If we also have a negative 5 times a negative 5, we'll get a positive. Those are great because it's essentially the same number. If we have a positive 5 and a negative 5, those are different numbers, then we would get a negative. So there's no way to multiply the same number by itself and get a negative number. Here you see in the slide you get a value error. Let's go ahead and run that. Sure enough, we see we get a value error, math domain error. So now we've seen what the square root is and how to use the Python square root function. Let's try an example of a real-world scenario that we might use the square root function. So in this example, we'll be looking at a tennis court. And in the sport of tennis, we have a player named Rafael Nadal. Here in this example, he'll be hitting a shot from this baseline, from the back corner of the court. Next, his opponent on this side returns the ball to right in this point next to the net and the sideline. Now, what we'd like to find out is how far must Nadal run to reach that ball to return it? So in tennis, we know a couple values. The baseline between these two lines is 27, and the sideline between the baseline and the net is 39. So with those numbers and a math equation, we can figure out the distance that he has to run from the back corner to the net to return that shot. The equation we're going to use is the Pythagorean theorem, which is a squared plus b squared equals c squared. And reworking that a little bit, we can get the square root of a squared plus b squared equals c. And this is the equation that we're going to be working with in our Python code, as we know how to do the square root of this value. So here we have the square root of a squared plus b squared equals c, and we translate that into our Python code, math.square root a squared plus b squared. Let's plug in those values. And b equals 39. And now we can calculate the distance that he has to run. So we have a squared plus b squared. And here we get 47.4 feet approximately, or 14.5 meters. And that's it. So far what we covered today is a brief introduction to square roots, the ins and outs of Python square root function, and a practical real-world example of using the square root function. I hope you enjoyed this. For more tutorials, check out Real Python on YouTube and the Real Python website. Thanks.